Kia ora Year 12. In this video, I'm going to quickly go through the answers to the assignment that I posted this morning on Algebra and Calculus revision. So what I've done here is I've taken the 2020 exam papers and just looked at changing the questions a wee bit, but they basically fit the achieved questions or some of the achieved questions in last year's Algebra and Calc exams. So let's look at the first one. So we've got a function and it's given to us as this. We have to find the gradient at the point where x equals -1. Then the second question is one where we're given a function and we have to find the x-coordinate where the gradient is equal to a particular value. The third calculus question here is a kinematics one where I'm given velocity and I have to find out acceleration. So let's go through those now. I'm trying to use a new stylus and it's a little bit funny, so apologies if it goes bad. Right, so here's question 1. We've got f of x and it equals x cubed minus 3 x squared plus 7. So f dash of x, differentiating that gives me 3x squared minus 6x. And I need to substitute in -1 into that function. So that's going to be 3 times -1 squared minus 6 times -1. And that gives me 3 plus 6, which equals 9. Okay, so now let's look at question 2, where we've got g of x is equal to 3/4 of x squared plus 5x, take away 4. So I'm just going to switch stylus back because this one's not working very well either. So differentiating that gives me g dash of x is equal to 6 over 4x plus 5. And now we need to find, so I can simplify that, 6 over 4, that becomes 3 over 2. And now I need to find where the gradient's equal to 2. So we get 2 is equal to 3 over 2x plus 5. So solving this gives me -3 is equal to 3 over 2x. -6 over 3 equals x, giving me a final answer of x is equal to -2. So that's my answer for that one there. Okay, let's just go back to the top and have a look and see what we've got for number 3. Well, number 3 is really easy. We're given velocity, right? So this is velocity, and we have to find the acceleration where t equals 3. So remember when we're doing kinematics that we start with displacement, and then to get to velocity, we differentiate, and then to get to acceleration, we differentiate again. So we're starting out here with a velocity function, which is a quadratic, so it's 4t squared minus 7t. And then acceleration will be 8t minus 7. We need to evaluate that when t equals 3, so we simply substitute in 3, and we get 24, take away 7. Which is 17, and the units will be meters per second squared. Okay, that's it for the calc questions. Let's have a look at these algebra ones. Well, question 4 is to factorize this expression. So that means we need to write it as the product of two factors. So there are a couple of ways to do this, but the way that I like the best is using grouping, where I take the coefficients. I've got the 6 and the -15, and together, multiplied together, they give me -90. And then I look at this, the number in the middle, which is the 13, and I need to have two numbers that add together to give me 13. Now, I've done a separate video on that called Factorizing by Grouping, and we've done that in class quite a lot. Ask me if you want more practice on this skill. So if we're thinking about those factors and you can't see them, one way to work is to think about a factor tree. So we've got 90. So what goes into 90? Well, we could do 2 and 45, and then we could do 5 9s. And we're looking for numbers that have got a gap of 13. Now, I know it's a gap of 13 because I've got one where I've got a plus and a minus in the end. So two numbers that are factors of 90 with a gap of 13. Well, you can see that 2 times 45 won't work, but 2 9s are 18, 18 5s are 90. So there's our answer. We've got 18 and 5. We want to have a gap of 13. So we're going to make 18 the big number and negative 5 the little number. And that's going to work to times together to give me negative 90. So we get 6x squared plus 13x minus 15 is equal to 6x squared. Now we do the splitting up, plus 18x minus 5x minus 15. And we factorize those, so we get 6x into x plus 3, and then take away 5 into x plus 3. So that gives us a final answer of 6x minus 5 times x plus 3. So there we go, there's that one done. Right, question 5 should have got much easier since we did the graphing topic, because what it's asking us for is to take this function and rewrite it in completing the square form. And again, there's a separate video on that if you can't remember this skill at all, but it goes like this. We've got x squared plus 8x minus 17. So we want to create the squared part, so we box that up and look at how we can make this into a perfect square. So we take that 8 and we halve it. We get x plus 4 squared. Remember though, if I expand that, I'm going to get x squared plus 8x, which is what I want, but I've got an extra 16. So I need to take out the 16 and then take out the 17 that was there to start with. So my final answer here will be x plus 4 squared minus 33. All right, the next 3 questions that I've included are all ones about logarithms. The Education Perfect is really good on this, and there are a few videos from me on these skills. So if we want to write this as a logarithm in its simplest form, we're using our rules that let us split up and combine logs. So the two main ones are these. The log of AB is equal to the log of A plus the log of B, no matter what the base is. And the log of A divided by B is the log of A minus the log of B. Okay, so in this first question here, we're going to use both of those rules to combine. So log of 3x plus the log of 8 minus the log of 2x can be put back together into one like this. It's the log of 3x times 8 over 2x. So cleaning all of that up, we get the log of 24x over 2x, which is simply the log of 12. Okay, on to question 7. 7 is a really, really nice, easy one. This is the first kind of log question that we learned when we learned how to switch between logs and powers. So this is so straightforward, I'm going to do it right here. We're using the loopy thing, right? So x squared equals 25. So x is equal to 5. Now just notice that x can't be equal to negative 5 because the base of a log is always positive. And then the last question here is this one. 5 to the power of 7x is equal to 119. So when we look at that one, we can think about whether we can do that without using our calculators. 5 to the power of 2 is 25, and then 5 to the power of 3 is going to be equal to 125. But we haven't got 125, we've got a nasty number, 119. So we're going to have to use our log rules to do this one, and a calculator. So we've got 5 to the power of 7x is equal to 119. I'm going to take logs of both sides. So the log of 5 to the 7x is equal to the log of 119. So bringing down the power, 7x log 5 is equal to log 119. Rearranging gives me this. 7x is equal to the log of 119 divided by the log of 5. So my last step will be that x is equal to this. Now I think this might have been a merit question, I can't remember. So that's my final answer, and I'm going to get that as a decimal, and I get 0.4242 to 4 dp. All right, so that's all for today. We'll be back into the probability for the rest of the week. Thanks for watching, and email me if you've got any questions on this.